Oh, welcome to Unstuck. Today's exploit needed no hacking at all. The attacker simply bought the vote. A DAO called the top token was drained of about $1.5 million because of one overlooked number. We'll reproduce the whole takeover live in Foundry, then fix it, slow and clear, with examples so it actually makes sense. Here's the setup. Top token was a DAO, the token holders vote on proposals, and whoever controls the majority controls the treasury. That's normal for on-chain governance. The fatal detail was hiding in plain sight: how many tokens existed in total. No private key was stolen, no cryptography broken. Just economics plus a missing safeguard. If governance security interests you, a like helps. First, let's understand how a DAO vote is supposed to work. In a DAO, your tokens are your votes. One token, one vote. Anyone can propose an action like minting new tokens or moving treasury funds. If a majority of the votes approve, the DAO executes it. The whole model rests on one assumption, that getting a majority is hard. Watch what happens when it isn't. Tope token's entire supply was just 16,384 tokens. That means a majority is only 8,193, a number you can simply buy on the open market for far less than the treasury is worth. Think of a company where owning more than half the shares costs $100, but the vault holds $1 million. That's the whole exploit in one sentence. Control was cheaper than what it controlled. Here's the vulnerable governor. This line is the majority check. Do you hold more than half the supply? If yes, the very next line runs immediately. It mints tokens right now in the same transaction. There is no time lock, no waiting period, no second look. So the moment you own a majority, you can propose and execute a mint of any size instantly. By the vote, print the tokens all in one block. Let's run exactly that. The flaw: a majority holder creates and executes a proposal in a single transaction. No time lock, no delay, no check that the supply is too large to buy. Buy the majority, mint 10 million tokens to yourself, dump them for the treasury's real money. Nothing stands in the way. The attacker's bow buys 8,193 of the 16,000 majority. The pool starts with 100 with ETH. They mint 10 million tokens to themselves, dump them into the pool, and drain 99 with. Pool after 0. A takeover and a drain in one transaction. 4 moves. Buy a majority, propose and execute a mint in the same breath, print 10 million tokens, dump them into the liquidity pool for the real money. In the real incident, that last dump pulled 944 with about $1.5 million out of a balancer pool. And this isn't just the local test. We deployed this exact governor to the Sepolia testnet and verified it on Etherscan. Source code verified, exact match. So that's the real vulnerable code, public, with the flaw commented right there for anyone to read. Here's the governance takeover as a real transaction on Sepolia. The action: call, propose, and execute mint by the attacker on the vulnerable governor. Status: success. A majority holder minting 10 million tokens to themselves on-chain in a single call. And here's the payoff: the drain, a real swap transaction on the pool, pulling the WETH out to the attacker, not a slide, not a mock, a block explorer you can click through yourself. And now the fix, and it's a classic, a time lock. When a proposal passes, you don't execute it, you queue it, stamping an earliest execution time 2 days in the future. The mint can't happen yet, and execution checks that clock. If the delay hasn't passed, it reverts. Those 2 days are the whole point, a public window where the community can see the malicious proposal coming and react, exit, pull liquidity, or veto. Let's run the same attack against it. Same attacker, same majority, same mint proposal. They queue it, sell out, but when they try to execute in the same transaction, it reverts. Time lock not ready. The instant takeover is dead. The community gets its 2 days. And the fix on chain as well, the same execute call, this time on the time lock governor. Doc status: fail with the reason spelled out, time lock not ready. Execution reverted. the instant takeover becomes a failed transaction, right there on the Explorer. Side by side, the old governor lets the takeover drain the pool in one transaction. The fixed one forces a 2-day wait, and the single transaction attack simply reverts. The fix isn't clever code, it's a mandatory pause. The takeaway is beyond DAOs. Put a time lock on every privileged action, minting, moving treasury, upgrades, so nothing critical is instant. Make voting power genuinely hard to acquire. A large supply, snapshot-based votes that resist flash-loaned buys, and size your quorum against the real supply. Above all, a mandatory delay gives humans the time to stop a machine that's about to do something catastrophic. Recap, a tiny token supply made the majority cheap to buy, and with no time lock, the attacker went from buy to mint to drain in a single transaction. The fix is a queue plus a time lock, which turns the instant takeover into a 2-day public window. We reproduced both live, pool drain to 0 versus the attack reverting. Quick one, if these breakdowns help you write safer contracts, the wallet's on screen, and there's a Ko-fi link in the description. Every tip funds the next one. Now over to you. Tell me in the comments which hack you want reconstructed next, and I'll build it live just like this one. If it helped, hit like and subscribe. This was a generous size reconstruction. The lesson, not the names. See you in the next one.